Hello everyone. So today we are going to do revision on the gravitation chapter, that is continuation. So in the previous class we have discussed the question and answers. In this class we are going to solve problems based on the gravitation chapter. And that first question is numerical questions. 21st question it is, let us find force of attraction between two blocks lying 1 meter apart. Let the mass of each block is 40 kg here. So that means we have to find out force of attraction between two blocks. Each block will be having 40 kg. Its mass is given, both the blocks, and the distance between these two blocks is given as 1 meter. It is the distance. So first we have to write what is the given. So we have to find out, let us find the force of attraction. Force of attraction F we have to find out. Mass of one block 40 kg, mass of second block is another one block is also 40 kg. Distance between them is 1 meter distance, and you have known capital letter G value is 6.67 into 10 raised to the power minus 11 Newton meter square per kg square. So this is the constant value. So if we substitute in this formula, if there is a question called calculate the force of attraction between any two objects, for example Earth and another planet, Earth and the moon, in all those cases you have to consider this formula, that is F is equals to G m1 m2 divided by d square, or if they have given radius means you have to take it as r square here. So we have to substitute the values. G 6.67 into 10 raised to the power minus 11 into m1 into m2 is nothing but 40 into 40 divided by d square means a distance square, 1 square, that is 1 into 1, you will get it as 1.60672 into 10 raised to the power minus 7 Newton. So unit of force is Newton. Next question is, the gravitational force between two objects is 49 Newton. So 49 Newton is the force is given. How much distance between these objects be decreased so that the force becomes then double? So that means force between first initially you have to consider the force between two objects is 49 Newton. How much you have to decrease the distance? You know what is the relation between force as well as the distance. If you know force and distance are inversely proportional to each other, if I am going to decrease the distance between the two objects, means the force will become the increase. That means how much I should decrease the distance so that force will become double. Force is becoming double means here the force is 49 Newton. Double of 49 Newton means 49 into 49 means you have to get it as 98 Newton. So we have to get that 98 Newton means how much I have to decrease the distance here. So to understand that, to solve that, we'll consider let r be the distance between object of mass m1 and m2. So we are considering two objects with mass m1 and m2, and the distance between them I am going to consider as r. So initial force between them is F is equals to G m1 m2 by r square, isn't it? R square means distance between the two objects we have considered. Initially when the force was 49 is equals to G m1 m2 by r square, that is the initial value before decreasing the distance. Now the distance between them is reduced to x. So this reduced distance I am going to consider as x. So the force between them will become twice. We don't know how much I am going to decrease, but I am going to decrease that value, that I am going to consider as x, so that the force will become double. So the twice it become. Twice means 2 times of F. 2 into 49 means, that is you are going to get 98 is equals to G m1 m2 by x square. X square means this is the reduced x here. Now we have to divide equation 1 by equation 2. This is the equation 1. Divide this divided by equation number 2. So you are going to get G m1 m2 by r square divided by G m1 m2 by x square is equals to 49 by 98. Now when it goes to numerator, x square by r square is equals to 49 divided by 98. So when I cancel this, I will getting the value as x square divided by r square is equals to 1 divided by 2. So it is nothing but x equals to square root will become, so r divided by square root of 2. So this says I should decrease the distance by 1 by root 2. 1 by root 2 times if I decrease the value, you can see f is inversely proportional to distance square. So now if I am going to decrease the distance, so what is the value distance I am going to decrease here? Distance I am going to decrease as 1 by root 2 whole square. 1 by root 2 whole square means, so root and this will cancel, so the force will become double here. So that f will becomes 2 here. So that means when I decrease the distance between them by 1 by root 2 times, then force I am going to get it as double. Next question is, two bodies A and B having masses 2 kg and 4 kg respectively are separated by 2 meter distance. So distance between the two objects, that is 2 kg and 4 kg object, is 2 meter. Where should a body of mass 1 kg be placed so that the gravitational force on this body due to the bodies A and B will become 0? So that means you will consider A and B as the two objects here. So A and B are the two objects. The distance between these two objects is 2 meter is the distance here. Now I have to place a 1 kg object, that is object C I have to place in between them so that the force of gravitation between them becomes 0. That means before placing this object C, there will be a force between A and B objects, isn't it? When I keep the C object in between them, the force of gravitation between them becomes 0. Why? Because there is another one object, so that there won't be any force between A and B, but there may be a force between A and C, and there may be a force between C and B, isn't it? So that is why the force between A and B won't be there, but the force between A and C will be there and C and B will be there. So that here the force of gravitation between A and B will become 0. Now I have kept in between them. We don't know whether I have kept exactly at the middle or somewhat greater or lesser. We don't know at what distance I have kept the C value, but I have kept the C here in between the A and B so that the force of gravitation between them has become 0 now. Now we have to consider what are the given. So mass of three objects and distance I have kind out. So now when I place, let the body C be placed at a distance d from A, gravitational force between A and C. Now let me consider A and C object. Two objects separately I will consider. Next B and C separately, because A and B don't have the force of gravitation between them. Now only force of gravitation is there between A and C and as well as C and B here. So formula we are going to consider as FAC is equals to GMA MC, because A and C are the two objects. So A value 2 kg and the C value is 1. So that is what you are getting. So FAC is equals to 2G divided by D square. Similarly, the gravitation force between B and C, if you consider FBC is equals to, so same thing, we are going to substitute it. So here you have considered this two forces. I think you are clear with A, B and C here. Okay. The distance between A and C we have considered it as D, means distance between A and B is 2 meter. Means what is the distance between B and C? The distance between B and C is, if it is this overall distance is 2 minus D is nothing but the distance between the B and C. So 2 minus D, so 4G divided by 2 minus D whole square. This is the equation number 2 and this is the equation number 1. Now, so when for a body C, the gravitation force will become 0 here. So now we have considered the body C, means the gravitational force will become 0. That means force between A and C is equals to force between B and C. Now we will substitute those values. So it will get 2 minus D. These two will cancel. G and G will cancel. So 2 minus D whole square is equals to 2 into D square. So 2, this square I'll take the here, it becomes square root. So 2 minus D is equals to D square and root will cancel. So we'll get root of 2D. So now when I take the d values separately, root of 2 plus 1 into d is equals to 2. So d will become 2 divided by root 2 plus 1. So when I substitute the value, I am going to get distance is equals to 0.83 meter. That means if I have considered A and B as the object, C is the another object, the distance between A and C is D I have considered. So that means distance between A and C is 0.83 meter. That means C I have kept near to A and far away from the B. Not exactly it is in the middle. If I got the distance as 1 meter means I can say it as the C object I have placed exactly at the middle between A and B. So, but now we have got 0.83. 0.83 means it is less than middle one. That is why the C object is placed at a distance near to the top of the object A.